Okay, that's number 3. So number 4 is asking how many grams of chromium-2 are present in 1.16 grams of chromium-2 nitrate. And number 2 says how many grams of chromium nitrate can be made from 4.49 grams of chromium-2. Okay. So number 4 is asking, so I have chromium-2 nitrate, and I have 1.16 grams of chromium nitrate. So let me write this down. 1.16 grams of chromium nitrate. So chromium here, I'm going to look at my periodic table. Chromium here belongs in group 6 here. So Cr here. And it says Cr2. So I'm going to know that this charge is actually a 2+. So Cr have a 2+ charge, and nitrite is one of our special polyatomics, right? So if I recall, nitrate has a charge of NO3 minus. Nitrite will have a chemical formula of NO2 minus here. So this is NO2 minus here, which means my formula for chromium nitrite would be Cr NO2 and 2 here. So this here will be my chemical formula for chromium nitrate. And again, I have 1.16 grams of this. So it's asking us how many grams of chromium-2 are present in 1.16 grams of chromium nitrate. So what I'm going to have to do is I'm going to have to find the moles of this compound here. So I have 1.16 grams here. So so that's my mass here. So mass here is 1.16. I'm going to have to find the molar mass of CrNO2, right? So the molar mass would simply be chromium, which is 51.996 is my molar mass of chromium. So I'll write that down. So it'd be 51.996 plus how many nitrogens I have. In this case, I have 2 nitrogens, right? This N here has a subscript of 2 here. I have 2 nitrogens, so I have 2 times 14. I would assume here is 14. So 2 times 14 here is 28 plus 28. And then here, oxygen, it's O2, and I have another 2, which means I'm going to have O4 here. So O4, again, my oxygen here has a molar mass of 16. So 16 times 4 would give me 64 grams per mole, right? 64 grams per mole. I'm going to sum all this up to give me my total molar mass for chromium nitrite. I'm going to get 51.996 plus 28 plus 64 will give me 140.996 996 grams per mole. So 140.996 grams per mole. And then also, so I'm going to have, this is my molar mass here, and I'll find moles specifically, right? Moles of the entire compound here would give me, so I'm going to get 1.16 here. I'm going to divide it by the molar mass, which is 140.996 here, which would give me a value of this 8.227. 227 times 10 to the negative 3 moles here. So this will be my moles of chromium nitrate. And what I'm going to do is with this mole value here, I can figure out, okay, what this is my total amount of moles here. So how would I have to break it down in terms of atoms here? So I'm going to have to break this element down to atoms and see how it creates this how it fills up this moles here. So think about CrNO2, right? CrNO2 and 2, right? So if you break this up into your atoms here, you can visualize this as you have 1 chromium. Let me use a circle too here. So you have 1 chromium atom, and you also have 2 nitrites, right? You have 2 nitrites here. So you also have you have NO2, and you have NO2. So this is how so these are the components of your CrNO2, right? So you have chromium and you have 2 nitrite polyatomic ions, right? So in order for this to have moles here, what it's comprised of, again, it's comprised of 3 parts, and they all play an equal part in creating this mole value here. So basically, if I have 3 parts here, I'm going to divide this mole value by 3 in order for me to get how many moles of chromium are there specifically, because I only care about the chromium ions here. So if I divide this number by 3, so I'm going to divide the number total by 3 here to get me basically the moles of specifically only chromium here, which is 2.742 times 10 to the negative 3 moles. And what I could do with this is I can convert this back into my mass here. So if I want to convert back to mass, again, I would have to simply just use again, mass equals moles. Oh, sorry, moles equals mass over molar mass. So I have to multiply this by our molar mass of our chromium. So this is 51.996 grams per mole to give me the grams of chromium here. So I'm going to take 2.742 times 10 to the negative 3 here, times 51.996, which would give me the grams of my chromium here, which is 0.143 grams of chromium. So this here is my grams of chromium in chromium nitrate. So let's see here. So let me just see if they got the answer here. Moles is 1.16 divided by, so this here is correct, and the moles of here, chromium in the samples times 52, 0.082 times 0.41 times 52 give me 0.416. So they're just simply actually doing, so they have the moles here, and they're actually just converting it back into molar mass here. So they're not even, so they're actually not even dividing by 3 here, and they're simply just moving towards they're simply just multiplying by the mass to get the moles here. So actually, I don't think you have to divide by 3 here. So I think I actually got the, sorry about this. So again, I think I divided by 3 because I thought we were doing a multiple ratio, and instead we're not reacting with anything. So this is actually my fault here. I thought we were reacting it with something, where in reality we are just calculating the moles here. So this here, I don't need to divide by 3 here, and I can actually just simply convert it back into mass here by multiplying this by this number by 51.6, so 8.227 times 10 to the negative 3. I can simply just multiply it by 51.996 to give me the mass of my chromium here. So sorry about that. So it's 8.227 times 10 to the negative 3 times 51.996. So this would give me 0.427, and they got 0.4, kind of close here, but 0.416 series grams, and then I can multiply 0.227 times 10 to the negative 3. I can multiply that by whatever 28 plus 64 is to get the mass of my nitrate here. So it's 92, which would be basically 1.16 minus 0.427 to give me the remainder of my moles here. So this is 0.733. Yeah, 0.733 grams of NO2. This is CR here. So this here would be like the mass composition of chromium nitrate. And then finally, B is asking me how many grams of chromium nitrate can be made from 4.49 grams of chromium 2. So what you could do with this one is you could either take a percentage to figure out this problem here, or you could just use, again, mass to moles, right? So if I were to do B as well, it says how many grams of chromium nitrate can be made from chromium 2. So if I have Cr2, I have 4.49 grams here. And again, and I can convert this to moles by dividing by the molar mass, right? I know my molar mass here is 51.996 grams per mole. So which means my moles here would be 4.49 divided by 51.996, which would give me a value of 0.0864 moles here, right? So this here is my moles of chromium. And what I could do is I could go back to my chromium nitrate here. So again, chromium nitrate, my chemical formula for that would be 0 CrNO22, right? So if I have 0.864 moles of chromium here, I can also figure out, again, how many moles I have of this nitrite group here as well. So again, what they did here, they again calculated the amount of moles like so. So to make 4.49 grams of chromium nitride here, the amount of chromium 2 requires 4.49. We're dividing it by the total molar mass, which is 144, or as I calculated, 140.996, and we're multiplying it by 52 here, because that's the molar mass of chromium here. So again, what you could do with 4.49 grams is again divided by, you can take 4.49 here and divide by 140.996 grams per mole. This would give you some value. Let me do this one. 4.49 divided by 140.996. So you get 0.0318 moles here, and you can multiply this by 51.996 to only get the mass of my chromium, or the mass required of CR2 required here. So this is 1.621 grams. So just like how they, or 1.655, sorry, 1.6556 actually grams of chromium here. So that means you can get how many grams of chromium 2 nitrate can be made from 4.49 grams of chromium 2. You can make 1.656 here. So the solution here is correct. The numbers are slightly off, but the logic is there. So solution is correct. Great analysis here. I got specifically slightly off numbers just because I have the molar mass was slightly different, so it's totally fine. That's number